So, let's get started. Hello, Berlin. I'm happy that on the second day, just at lunchtime, I got so many people already here. So I'm kind of proud of that already. Thanks for coming here. So my name is Johannes Hund. I'm CTO of a company called EcoG. So I promise I will not go too deep into advertising, but I at least want to give you a picture about what we do, because it will set a bit of frame about why those decisions that I'm going to be talking about today are important for us, and I think for the most of you as well. We're going to be talking about design decisions we take in IoT, creating a backend, and specifically we're going to be talking about make or buy decisions, or make, buy, or software as a service decisions. So a bit about EcoG. What we do is the IoT operating system for electric vehicle chargers, meaning we make chargers smart. We provide a software and we provide it as a service. That means as a charger manufacturer, you include our software and it allows to the open API access that we have on the device, the integration of many different verticals, of many different services. We're going to later cover some examples for that. So the two main focus groups we address as our customers are hardware manufacturers, people, companies that build chargers. So they get our software free of an upfront charge. They pay us as a service with the recurring updates. So we keep the software up to date. When there's a new vehicle out there and has a bit of quirks, then we take care of that, and they always have the latest software running on their stations. On the other side, we got a lot of business or service providers that use these open APIs to create what we call a microservice, an app that runs on the charger that connects to their respective backend. We compare it kind of to the Android for charging stations. So to give you some examples what this can mean, we got hardware manufacturers that provide charging stations, and they want to have very deep insights. They want to have monitoring. They want to have predictive maintenance, and we can enable this for them. Then we got fleet operators, corporate fleets. If you go to another site, you don't only want to book a meeting room, you want to book the charger as well, so you can charge your car and drive back home. Then if somebody else is already charging there, opportunistic, I book the charger, I can unplug this other guy, can plug myself in, and when I drive off, I can plug this person back. That allows us a much higher utilization of the installed base, resulting in a higher CAPEX, in a lower CAPEX. We got utilities. So if you consider an EV charger is a very high load for the grid. So they want to have at least forecasting, at least very detailed monitoring information about the chargers. We can provide it to them. We can even provide special tariffs where they can influence the charging process or set maximum powers. For site owners, they will want to integrate it into their building operation so that they do not exceed the maximum power that they are allowed for the station, for the grid connectivity. And with the open API, they can provide further inclusion into their building management system. We got some deals with commercial vehicles, mainly for disposition, so that if you have a shared electric fleet and you operate this as a shared fleet, you want it to be ready at prime time where you can charge higher fees. So how can you incentivize users to charge in the off times? And that's something we can do for them as well. In the retail business, what if I tell you if you buy something for $10 in my store, I'm going to take care that you don't have to pay for charging your car. Or you book an appointment with a lawyer that's in the mall, and they will book the charger for you. These are all use cases that we can provide for the users. For that, we have a backend on AWS, as well as software on the charging stations. Now, who is the people behind this? The team are 3 people. The founding team is 3 people, and you see we are still a kind of 2 pizza-sized team in the whole company. First of all, Jörg, our CEO, was the one expert for electric mobility charging within Siemens. So he's also one among the people that wrote the standards how an electric vehicle and charging infrastructure communicate. We've got Manuel, he's also here today. He's a startup rock star, so to say. He used to found 2 companies before he joined Siemens in the venture capital arm, and was doing strategic investments for Siemens in the mobility space. Now he's joining our company as well. My background is Industrial IoT. I was leading a task force within a group called Web of Things, which is defining a web application layer for IoT in international standardization. And I did architect several IoT platforms within Siemens. One of them is now known as MindSphere as well. And you will hear a lot about it from the Siemens guys on this stage already also. So we got several companies that are backing us, and as I said, we only have 9 people working for us so far. So we're a quite small company, which also brings us a bit to the perspective of this talk. It's really about building speedboats, building something very quickly, experiment, fail, and learn with it. So whenever this comes, your decisions will be differently than if you build something that is from day one, you have big teams behind it, and you can do a lot of stuff yourself. When you're in a situation like most startups are, or in corporates in smaller teams, you have to be fast-moving, you have to be very early to experiment, to fail, to readjust what you do. And for that, these incremental approaches, build an MVP and then increment over it. First, take whatever you can get that you don't have to do it yourself, and then if you see it costs too much, you can still do it yourself. There's a bit a red line that we will see more and more, so go into the agenda. We're going to be talking about make or buy decisions generally, what it means for you along the product lifecycle or along the operational layers. And also, I'm going to give you some landscape of how a typical IoT stack normally looks like. And we're going to deep dive into one example, which is device management for IoT devices, and talking about pros and cons when you make it yourself, what comes at what price, for what benefit. So I can give you some rules of thumb that we use, but as you know, it's always a bit case by case. But maybe your situation is kind of similar to ours, and they apply for you as well. So starting out, what we mean by the make or buy along the life cycle. So it's easy to say, if you buy something, it costs you more than if you create it yourself. And you got the developers sitting around, so why not create it yourself? But if you see it on the long run, when you create software yourself, you don't pay for it, you don't buy something for it, but you're the one that integrates it, you're the one that maintains the software, you're the one that, if you have found a bug, released an update, you roll out the updates on it, and you do the operation for your software yourself. If you buy a software, you might have to pay for it for commercial software. You might be the one that integrates it into your stack. And if you get updates, it's still up to you to roll out the new version of it, and you do the operation for it. So the game with open source is a bit differently. You don't pay for it, but it might be still that if you have something that you created and you just want to share, let's say, the maintenance, there might be other companies and you team up for them. You're still the one that creates the software. You still have to integrate into your stack. When you get the chance that you get help maintaining it, or somebody else did put that feature that you need in, it's up to you to update your software. And the operation will be at you. Then the great difference we see when we talk of SaaS software here is, yes, you pay for it, and you pay for it month by month, but the only thing that's left for you to do is to integrate it. And once you integrated it, you can still roll your own servers. For example, if you have a SaaS software that is based on an open source software, as many of the components in the AWS stack are, you can roll your own if you see something that you need to add a new feature to it, if you see something that you need a new version that you don't get as a SaaS. But for starting out, you can take the SaaS, and it takes you as long as you need to go before you have something that is so special that you need to roll your own. So summing this up, make or buy along the life cycle is the one message that I always give people, like, owning software is expensive. Always be aware that your decision will have a long outreach into the future. And when you take the decision, be aware that what does it mean if I do it myself? What does it mean if I take it as a SaaS? It can be that one is more advisable to the other, but as I say, always choose your battles wisely. Choose very explicitly, if you do a software yourself, then do it, but then really do it in a way that you would do a product. So really invest in those resources that you do in really invest your resources in those softwares you do yourself. So when you do it yourself, you still have a lot of choices to do, like how much of that software that you do yourself is really need to be done by you. So picking up what Dr. Werner Vogel said this morning, this shared responsibility model, like how much of the responsibility do you need on your side? So talking of infrastructure as a service offerings, you more or less get the hardware operated. The rest is up to you, updating the system, patching for security, running the applications, and all of this can be so special in your case, but in most cases, it is just not. So you want some higher level offerings. For example, managed applications. You will most probably not write your own database in you. You will most probably have some way that you get a managed database or other applications that you just provide the number of instances. You can still scale it yourself, and you just use the applications. All the rest is provided by the cloud provider. Now, if you take that one step further, when you containerize your servers, you just roll out your containers, and everything that's coming below the container level is operated by the service provider. Such as example, Fargate. I put the Kubernetes service of AWS here. It is, in the moment, one of those managed applications. But if you see where it's going with Fargate, I would be surprised if you don't get an operated service for that as well. So that brings us also to the next level of it, which is nowadays known as serverless or FaaS offerings, function as a service offerings. So the big difference here is you really just write what happens if that event comes there. You write event handlers, such as in Lambda. You store or access data, such as in Aurora. And it's more or less if this, then that. That's your job to do. Anything else is operated, and you just pay for the value you get. So one level higher even is you don't care how it is done. You just use what's there. So in there, for example, S3. Right? You don't know which server is there and what exactly happens. You don't write code for it. You just use an API. You integrate a REST API in your application, and you're done with it. So the main difference I see here is, when we wrap this up, it's not only writing the code. It's also the way you write the code and you deploy your code. Because the higher the abstraction layer, the more you can already, or the more it resembles the local host of the developer to the production environment. When I'm running on top of a serverless stack, I write an event handler in Node.js, and it will run on such a high abstraction layer that it doesn't really matter if it runs in the cloud or on my local host. If I use the API, it's exactly the same call. However, if I really run it on infrastructure as a service, I need to have the same base operating system, the same patch level, the same applications installed and running as we have in the cloud. So you see, the higher you can get with this abstraction layer, the easier it becomes to have immutable infrastructures, to have your DevOps cycle in a way that your cadence really gets so slow because your local host, where the people develop, resembles very much to what you have in the production environment or in the dev stages. So it also allows you to go faster from that local host to the actual production, because you don't need so many steps in between. You can test it very automatically. You will still want to test it well, but you can automate more of it, and you can move much faster. So this higher abstraction layer, we always call it like standing on the shoulders of giants, meaning somebody else does a lot of heavy lifting for you, and you can focus on what really differentiates you. With that, I would like to take a look at what a typical IoT stack might look like if you build it on the AWS stack. So starting up there where users and applications are, we got something we call an offbound API. That's from where the calls get, where our apps, our dashboards, our users are interacting with the whole system. We most probably have some kind of API gateway. We might have AppSync. We might have a Lambda functions in there that will then access some kind of data layer. To secure all this, we are going to be using Cognito or IAM. It really depends on what model we follow. However, we got a lot of building blocks that we can ready to use and pull in there. And then we usually have some different ways of databases. So you got master data, which is a device registry, which is some data about the users who may access what on which devices. And then you mostly got some kind of streaming data where we got now a time series DB offering from Amazon, for example. There used to be Elasticsearch in that ballpark. And you most often have something like a state DB where you will run on Dynamo or something in memory, where you just want to cover a lot of state and just want to have the latest state of all your devices so you can quickly have a live view or dashboard or have some aggregations in there. That is all powered by lower layers, which are a southbound API. And there will be also some kind of notion of device management. You'll want to roll out updates and so on. And we're going to deep dive into that on the next slide. However, we always see a bit of confusion in the IoT space. What do we mean by the thing or the device in the field? It can be something that is like edge level or gateway level, which runs on embedded Linux. And we can be talking about pure microcontrollers, where we usually have bare metal stacks. FreeRTOS is one offering from AWS for that. Or we got Greengrass on these higher layers, which usually is some kind of Yocto build or an embedded Linux build. It might go up to Debian systems. To complete it, you usually separate from this northbound API the API that you as administrators are using. You don't want to mix that in one API because you will have totally different access patterns. You will have monitoring for all the services and so on. And I usually advise to have a really separate API for this that is accessed by your operators. Often you also do offerings like you have a dedicated VPN, so a virtual private network that you can access from your customer side on, but it's not in the public internet. So really keep that admin API far from where your users are accessing it, and separate where your devices are accessing from where your users are accessing it. Now with that, let's have a deeper look into device management. So there is an offering from AWS IoT. It's based on the IoT core and gives some extra functionality on top of that. It's mostly about device provisioning, so meaning I want to roll out a new device that's in the field, and I want to make it known in my backend. There's something like a device registry, which allows indexing and searching of all my devices based on the current state or based on some metadata that are assigned to it. And this device provisioning brings a new device into that. If I use the device-sided offerings of AWS, I can make use of something like remote logging for my functions in Greengrass. I can use remote logging for FreeRTOS. And I got OTA updates, so meaning over-the-air updates. I just send out a command, please update to this version, which is stored on S3. And then it gets downloaded and updated. However, there are situations like in ours where you cannot run Greengrass, simply because in our case the boards have a smaller footprint regarding memory, regarding CPU size, or we don't run bare metals like that we can run FreeRTOS. So there's something we saw we have to do ourselves, probably because we didn't find a service offering out there. And the first thing we did, a short list about these features we will probably need down the road, which is about we want to have a separation between applications and the system, and we want to have package management for those applications, right? Or we want to start and stop services. We want to access the logs of the system, network configuration, who may access the system, like directly access it. Or we need to synchronize time, something as simple as that. And we have triggering of file up downloads. And there's a whole bunch of services that we're going to put on top of that, where we just saw we cannot fulfill that with the offerings that are out there. We screened it, we shortlisted it, and that's something we decided, okay, we're going to do it on our own. Now, it does, of course, have pros and cons if you decide to do it on our own. And the definite pros are it has all the features you need or you think you might need. And it's lightweight enough if you have a smaller footprint. In our case, it hits the right performance level. So we do have an application that runs. And we don't want it to be impacted by our management features, right? So we also want to minimize external dependencies. So we don't want to have a lot of runtimes and libraries that we need to install just to run our management functionality, but somehow have that as one package that we can download, install, update, and also have a smaller attack footprint when it comes to securing it. So we definitely see this as a differentiation, because our USP that we offer our customers is we can operate it. It makes it easier to operate. It makes it easier to access stations. So it's something that is really on a critical line of business. And that made the decision for us to do it ourselves. However, you do have to keep in mind what it comes as cost with it. So these are the efforts of building something, and it's really just having coders there to program it. That also includes that in the future we will have to provide bug fixes for it. We have to test it out. If there's something like Spectre, Meltdown, or any other security issue coming up, we have to look out for the CVEs for it, and we have to take care that it's maintained. There's nobody going to do this for us, of course. And we don't know really the total cost of ownership for it, as we don't know how long it's in the field, and we don't know what it really costs to keep it patched up and updated. There is really an unknown number we have to put into a bill that we cannot really, we can estimate it, but there is always a great uncertainty what it will cost us in the long run. And we are definitely locked in on this. Once we spend some man-month and create this thing, it's going to be a very hard decision if we just say, OK, we put it in the trash and we do something else. And it binds very valuable resources. As you saw, we are a very small team. If you have some people put exactly on this small feature, then they're missing somewhere else, right? And we will fail quite late. So if it's the wrong decision, the day we will find out that it is the wrong decision is long, long in the future. So, and you will definitely need some more know-how about all these embedded Linux things, that if we have some offering that would give us this as a service, that is something we would all save. So as you see, there's a lot of decisions back and forth. And there's some reasons we did come up with that we kind of live by. These are the points where we say, then we have to do it ourselves. Just if it's your USP, if it's the reason why people give you money, that's definitely something you will want to have yourself, because if you get it somewhere as a service, you're just reselling it, then what's the differentiator you will have? So when there is something that really creates the core of your business, the core of the value proposition you give out, it's most likely the thing you want to do yourself. The second thing, what I call the critical core here, is a bit a different beast. That is something that you will need to do. It's not something the customer will even see or notice, but it allows you to bring the service that your customer pays you for. So it's something often that you need, but you're the one that sees it, that needs it, that operates it. And you see there's a bit of a difference between these two things. And this also brings me to the third point. Nobody does it in the way you need it. And that's really something you have to double and triple check. You all know this not invented here syndrome, that you just say, I don't like it. I need to do it by myself, right? So it's so easy to say, but that's really a danger. Just really be sure, prototype it. If there's something out there that might be an 80-20 solution for what you need, if it's not the right thing to do, to use that, and then just do the additional stuff yourself. And one thing that's always very hard to come by with offerings from outside is if it has to run on premises and in the cloud. It's getting better. We're getting, I think it's called Outpost in AWS, where you can run in a larger data center the services that we know from AWS in the cloud. But especially in Germany, you often very quickly get that requirement that, but it has to run locally. It has to run on-site. And in that case, it's always, mostly in my history, it has been a good choice to then do what I call a backend in a box, meaning maybe do a Kubernetes rollout, maybe do something that you can run publicly as well as privately, and then do substitutes. Like there is something that mimics the S3 API. So we use that when we run in a data center, and we were on public cloud, we use the actual S3. But that's always a kind of touchy, tricky thing if you have to run on-premise and in the cloud. So there's no silver bullet for any of this, but these are like indicators it might be that you have to build it yourself. Where I would be very cautious about this one, it's nothing out there that really fits my needs. So the rules to live by, and you see this with a grain of salt. The cost of building and maintaining your software, you will always underestimate them. So I really, really seldom heard of a software project that was exactly in the budget, exactly in the time. So I would be surprised. I will greatly be put wrong with that, but so far, most of the projects I saw were a lot more expensive, a lot bigger than thought before. And if your customer does not pay for it, or it's not something that differentiates you in your operations, in the way you do things, then don't do it yourself. Try to find somebody that does it already. If there's nobody out there, then consider if it's really you alone that has to be it. If it's nothing that differentiates you, maybe go the step and open source it. There's no guarantee that if you throw out the code on GitHub, that other people will pick it up. So there's still a long tail behind that, getting developers on your open source project. But at least there's the possibility that you get some patches, that somebody uses it as well, and you have some people teaming up on your resources. And another thing of this, don't do operations. Whenever there's somebody that can do the operations for you, that's the thing that really is only a cost center. Even if you excel at operations, the only thing it gives you, it's that you spend less money for it than you would have. So whenever you can give whenever you can give operations out to somebody that will do it for you, really consider doing it. And if you have to, automate it as much as possible. We had a lot about infrastructure as code. We had a lot about immutable infrastructures already today. And it's really the point where you can save a lot of money and a lot of gray hair. And that's also this raise cattle, not pets. I mean, it's a very word you hear it very often. I don't think it's a new one for anything. But really avoid snowflakes where you can. Try to make everything automated. Try to make anything, in a way that you don't fix that one thing, but fix everything of it. And of course, if there's a SaaS for it, really consider in the early stages using as much as a service as possible. Even if you say it's getting very expensive once we scale up, and we then need to do something that we now take as a service for ourselves. But for this first time, if there's a SaaS for it, even if it costs more money, why not use it? And later on, you have the option to make it more cheap, but you want to prove your product market fit first. And then you can still trim down the cost, design to cost. Even for a software version, that means we now do something ourselves that we can have as a service, but we have a good reason to do so. So just some ideas for you. With that, I would like to conclude my talk. I'll be happy if there's questions from here, and please rate when you leave the area. With that, thank you very much for listening for me. I'm very open for questions right now, also here on stage. And my name is Johannes Hund. I work for EcoG. We create a future for electromobility charging. Thank you very much for this talk.